In AS, you have two trig identities which you need to know. In A2, it gets a lot worse. You have so many that you need to know. In AS, there's only two. The first identity is sine squared theta, or x, plus cos squared theta, or x, equals 1. Okay? You might see 3 lines in your equals. That 3 lines, or those 3 lines, just means they are always true for all values of theta. That's why you would use the triple line. You can essentially use both there. Doesn't really matter too much. That's identity number 1. Identity number 2 is tan theta is the same as sine theta over cos theta. Okay? So those are the only 2 you need to know for AS. Where it gets difficult is the application and the manipulation of them. We're going to look at a few questions and you're going to understand what I mean by that. So it says, simplify the following expressions. You're going to use your identities in order to simplify them. The first one, sine squared 3 theta plus cos squared 3 theta. You're going to use the first identity, sine squared plus cos squared equals 1. Whether it's 2 theta or 3 theta or 200 theta, doesn't matter. So for A, your answer, sine squared 3 theta plus cos squared 3 theta. If you simplify this, you just get 1. Okay, B. 5 minus 5 sine squared. Okay, if we factorize out the 5, what are we left with? 1 minus sine squared. And now you can use identity number 1. Sine squared plus cos squared equals 1. How can you manipulate this or rearrange it so you get something similar to this? You can take that sine squared to the other side. 1 minus sine squared theta. This you can plug in. So 5 cos squared theta. So 5 cos squared theta. That's that fully simplified. So do you see what I mean by taking an identity and then manipulating it? That's essentially what you're doing. So with C, sine 2 theta over root 1 minus sine squared 2 theta. Okay. We can use identity number 1. We already got to this point. Cos squared equals 1 minus sine squared. How would I get a root there? Square rooting. So if I square root, I get 1 minus sine squared theta. Like I said before, it doesn't matter if there's a number in front of the theta. So that's equivalent to sine 2 theta over cos 2 theta. Okay, because I'm making use of this manipulation of the identity. And now you can use identity number 2. Sine theta over cos theta equals tan theta. So in this case, this is going to equal tan 2 theta. That's it. That is how you use both identities. It is difficult. It's not easy by any means. You just got to keep trying. You just got to get through as many questions as you can until at one point it clicks. I myself, when I was studying it, it took me forever to figure it out. It took me ages. But eventually I got there. It's just a matter of how much time you put in doing the questions. Okay. I want you to give this one a shot. Now here's what you're going to do, or here's what you can do. You can split this. You can focus on the left-hand side and try and turn it into the right-hand side, or you can go the other way. You can start from the right-hand side and turn it into the left-hand side. Whichever one you start with, you want to specify in your working out. As a hint, I would say start with the left-hand side. So you're going to start with this, and you're going to try and turn that into 1 minus tan squared theta. If you've done that successfully, there you go, you've proved it. That's all you have to do. You're going to make use of your identities and any other mathematical knowledge to get there. Give it a shot. Okay, how did you get on? In the past, when I've given any of my students this question, they find themselves very lost, and rightfully so, because when you're doing this for the first time, you're like, I would never get this. But it's okay. I'm here to explain it to you. So, the first step would be to turn your numerator into a set of double brackets. If you notice, your numerator makes use of difference of two squares. So, cos squared theta plus sine squared theta, and then cos squared theta minus sine squared theta, all over cos squared theta. From this point, can you use any identity? Yeah, you can use the first one, sine squared plus cos squared. That's your first bracket. So making use of sine squared theta plus cos squared theta equals 1, you get 1 cos squared minus sine squared, all over cos squared, which is just going to be the same as that. In your working out, if you're going to use an identity, write the identity down. It's always helpful, and it could potentially be a method mark. From this point, you can split the fraction like this. And now you can simplify. Cos squared over cos squared is 1. And then we can use identity number 2. Sine theta over cos theta is tan theta. So that means sine squared over cos squared is tan squared. There you go. It says, prove that left-hand side equals right-hand side. I just did. I started from the left, I made my way to the right-hand side. That's how you do that. It is hard. Like I said, it's gonna take time. It's Not necessarily going to click first time for everyone. You are going to get stuck. That's part of it. Trigonometry in A-level is very difficult, but I would very much suggest spending the time to go through as many questions on this topic as you possibly can. The more time you spend on this now, the better off you're going to be later, because this does come up later on in the book, potentially, I think, but especially in A2. It comes up in A2 a lot. There you go. That's how you do trig identities.